Hello and welcome to the TES Secondary Maths Resource of the Week with me, Craig Barton. Now, I'll be honest with you, I'm a little bit obsessed with sequences and crucially how sequences are taught. And this stems back to a few years ago when I did a load of research on the most effective way of delivering sequences. And a lot of my reading uncovered the fact that if you can approach it from a geometrical perspective as opposed to a straight algebraic perspective, it really helps students get that more solid foundation in terms of representation and prediction and generalization and so on. And what I mean by that is, as opposed to showing kids a sequence that goes 2, 5, 8, 11, 14 and so on, and getting them to realize that that's 3n take 1, it's far better for them if you can show that as a geometric pattern that they can understand and look at and make predictions on and draw the next one, and then start to bring in those algebraic representations later on. So with that in mind, I've often been a fan of the wonderful Visual Patterns website. And if you haven't used that, it's just it's a treasure trove of, well, over 200 wonderful patterns that you can get kids to analyse, and you can bring in the algebra if you want later on. And that's why I've kind of fallen in love a little bit with this wonderful resource, Representing Growing Patterns, because it takes that idea and flipping heck, it extends it loads. It's a wonderful resource. So let's have a look at it. It comprises of a PowerPoint and a PDF, but the PDF is just kind of a paper-based version of the PowerPoint that you can use for printing. So this is what the PowerPoint looks like. And I think what I'll do is I will just go for a bit of a full screen. So there's the instructions, and this is just one way the author suggests doing it as a group activity and giving each student in the group one of these patterns to kind of fill out, and I'll show you them in a second, and then bring it back together with the group to share what they found and help each other out. And I think that's a lovely way of doing it. There's nothing wrong, by the way, with kids just working through these independently or in pairs and so on. So just bear that in mind as we look through this. So, little worked example here, which will really kind of help explain what's going on. So, every single sequence gets a visual representation, and these are uncoloured or not coloured in. I don't know what the phrase is for that. When you see them on the actual examples, then you get an nth term equation, and then this is nice. Then you get the table to see how they're growing. Then you get the graph, because how often do we do that? How often, certainly from a personal perspective, I very rarely relate graphs to sequences, but it's all the same thing. It's all related. And then if I just move my annoying head out of the way, a nice little sentence to work out how many patterns, how many blocks in pattern 1000 that I multiplied 1000 by 3 and added 1 and so on. So 4 different things, 4 key skills, well 5 I guess, that you can get from one pattern representation. And then there's a load of these. So if I just move through these now, so let me just sorry, I'd clicked off, there we go. If I come through that now, so you get loads of these patterns. So kids will be given that pattern. They'll be asked to perhaps colour in to see what stays the same, what's constant throughout it, what changes throughout it. Therefore, what's the nth term equation? Can they use that to fill out the number of squares? Where does the graph come into play? And then how would they work out the 1000th? And it'll be interesting to see which bits of this the kids find easiest, what comes first, what comes second, and so on. So again, colour in what stays the same, what changes, where do the numbers appear in that nth term equation. And sorry, that was something I really wanted to emphasise on here. It's a lovely thing. Where does that 3 appear in each of these representations? Where does that 1 appear in each of these representations? Really nice, and it just gets kids to understand so much more what sequences are all about. So yeah, there's loads of these, loads of different ones. And as we go through them, we'll see that all of these are linear sequences. But what I love about this is that this approach, and this is the same when you use any kind of picture approach, it lends itself perfectly well to bringing in quadratics without it seeming like a massive jump in understanding for the kids. So if I just go a little bit further, you can see the complexity increasing a little bit as we go through this. Classic little chairs with tables around it, representation there. But as we get a little bit further, then we're going to start to get, again, look at that pattern, what's going on there. So that will be an example of something that if you didn't have this diagrammatic approach, that's going to be incredibly difficult for the students. But I reckon they could probably have a go at that. It's got an asterisk by because it's a difficult one. But if you've kind of built them up through all these ones, maybe they're going to be all right with that, or at least they'll have a go. And again, this is where the quadratics start to come into play. But if students can start to see that as a single square, that as kind of bigger square, 2 by 2 square, and that as a 3 by 3 square, then they can start to build it up, and without having to fall back on the kind of quite tricky algorithm to work out the nth term of a quadratic sequence using second differences and all that kind of stuff. So look, I'm obviously incredibly biased because I've been looking into this research for years and this approach, but teaching sequences through a diagrammatic approach has been shown to be a really solid way of doing it. And now if you can use this resource to link it to the graphs, link it to patterns of numbers, it's just a complete package. So I just thought this was an absolutely sensational resource, and I'd use it with any year group. I would use it anytime I'm introducing sequences. And this visual patterns, I've used this in primary schools with kids as young as kind of age 6. They start to make generalizations with this, and all right, they're not using the algebra, but who cares about that? That's not the important bit about it. So look, a wonderful, wonderful, wonderful resource. I hope you find it useful. I'd use it with anyone from year 7 right up to year 11. Yeah, and that's just about all I've got to say about it. So I hope you found that useful. If you like the resource, hop back onto this page and just share your thanks with the resource author, and I'll return with a fresh resource of the week next week. Take care of yourselves. Bye for now.